Good morning, one and all. Today we will be touching upon IP version 4 addressing. So in IP version addressing, basically we talk about the IP address. So what is it? Basically it's an identifier which is used in the IP layer of TCP/IP protocol suite, and it is also known as an internet address or a IP address. So therefore, we will see now various characteristics of the IP address. So IP version 4 address is a 32-bit address which is uniquely and universally defines the connection of a host and a router to the internet. So IP address is actually the address of the interface. Now we'll see the features of IP addressing. Of the classical addressing, IP version addresses are unique. Each defines one and only one connection to the internet. Now, no two devices on the internet can never have the same IP address at the same time, right? However, if a device has connections to the internet via two networks, it has to. For example, if it's a router and the router is connected to more than two networks with his interfaces, then each interface will have a separate IP address. That is the meaning of it. Now, when we say that the IP version 4 address is a universal, that means once it is the address is given, it is accepted by any host, no matter to which corner of the world it belongs. So therefore, we say that IP version 4 addresses are unique and universal because they are accepted everywhere. Now, since we are talking about the IP addresses, we talk about the address space. So, if the protocol like IP version 4 is defining IP address, then it is basically talking about the address space also. Now, what is that address space? The address space is the total number of addresses used by that protocol. So, suppose if B is the number of bits which defines the address, then 2 to the power B, this is going to be the address space. Now, in IP version 4, since 32 bits are used for showing the IP address, then 2 to the power 32, that means more than 4 billion IP addresses are there. So that much is the space generated. So theoretically, if there are no restrictions, then more than 4 billion devices we could be connecting to the internet. Now we'll see what are restrictions later. Now, how do we write the IP address? So IP address can be written in three forms. First one, we can write it in the binary notation, that is base 2. We can write it in the dotted decimal part, that is base 256, and we also can write it in the hexadecimal notation, right? So what we will do is, however more prevalent is the base 256, we usually prefer the dotted decimal pattern of IP address. That notation we actually use. But we will see all the types in detail. So first we see what is a binary notation, that is the base 2 notation. So in binary notation, your IP version 4 address is displayed as a 32 binary bits, right? To make the address more readable, what is the condition? Either one or more spaces are, I can show you, one or more spaces are introduced in the 4 bytes, in between the 4 bytes. So this is how either the 4 octet we call it as, or we call it as a 4 byte address. So this is how in binary we can write it. Now what happens is, to write down the IP address in the binary every time will be cumbersome because you have to remember 32 bits. Therefore what we do is, and also we want to make it very compact and easier to read. Therefore IP version address is usually written in the decimal form with the decimal point separating the bytes. So this format is referred to as a dotted decimal. So each byte, what we do is we convert it to its decimal equivalent, and after that between the two consecutive bytes we put a dot so that it becomes a dotted decimal notation. Now we will see how it is converted. So any random number is chosen, that's a IP address with the binary bits. Now what we do is each byte we convert it to its decimal equivalent and separate it by a dot. So all the 4 bytes, this is how the cumbersome process is actually made very easy. So this becomes 128.11.3.31. So we are used to this type of a notation. That is your dotted decimal. Now let us see the example. Okay, now can we change the IP, given IP address into binary, from binary notation to dotted decimal notation? It's very easy. Each byte, we are going to convert into its decimal equivalent. It's very easy in our case. Right, so each byte we convert into decimal. What is the solution? The solution is in the 129.11. So this is a very easy way of remembering and writing the IP address in the dotted decimal form. So now, if we see the second example, right, what we can do is, since we are now used to binary to decimal and decimal to binary conversion, we can very well convert the given decimal, dotted decimal pattern into binary pattern. Since we all know all this, so therefore this also can be done. So this is how all those numbers we have converted into binary.